you can't pick the right statistical test, just ask you these 3 questions and you will never guess again. And if you answer them in the right order, the test you have to use is very obvious. So what can you expect from this video? First, you will see a real-life example on how not to pick and choose your statistical tests. We will look at the 3-question structure, which will help you to pick and choose the right statistical method. We will look at how you can apply this structure for your special data set. At last, we will look at what mistakes students normally make when applying the structure on their own data. I give you a real-life example on what most students do wrong. The first thing what students are doing is they're reading into many different methods like t-test, ANOVA. So you have many different tests for your choosing. And what the most students do, they take a week and look into every single test and are looking for, is this the right test for my data? And this can work for sometimes. Well, it will consume a lot of your time, but it will not give you the satisfaction, and you will always have the feeling like you're guessing what you're doing. The method I suggest is that you take a step back and you really think about what type of data do you have and what method do I need to answer my research questions. So not thinking from the test, rather think from your data set and your questions you want to analyze. Which research goal do you have in mind? For this, I have created the 3-question structure, which will help you to choose your test. How we can resolve this with a 3-question structure. What I'm suggesting is that you do not think from the test itself, but rather you think from the research question you're coming from. This is much easier, and this will help you even before you even have your data, because beforehand what tests you will apply for your analysis. All right, so let's start with the 3-question structure. Let's imagine we have our methods on the right side. For our use, we will have a few. So we take the t-test, the ANOVA, the correlation, the regression, and their non-parametric counterparts like the Whitney U test. And how do we get there? Can we decide which test we have to pick for our analysis? So the first question we have to ask ourselves is, do I want to analyze differences or do I want to analyze relationships? And if I can answer this, so if I have a hypothesis which states there are differences between group A or group B, or there are differences between date 1 and date 2, then I have a difference hypothesis which automatically rules out every relationship analysis we have to conduct. Namely, for us, correlation and regression would go out of the window. On the other hand, if I have a hypothesis which states a relationship, where I say the more sleep I get, the more productive I am, for example, then I have a relationship hypothesis which automatically rules out every difference analysis I can conduct. So let's start here. Do I want to see differences or do I want to see relationships? So the second question I have to consider is, what data type am I working with? And on the surface, this is really easy. If you go into depths, the internet is killing itself apart over this question. What data type do I use for which test and what works when, and so on. So to say it very easily, you can divide your data types into 2 categories. The first one is categorical data, and the second one is data you can scale, you can work with. How do I find out which type of data do I have? Very easy. Categorical data cannot be used in mathematical methods whatsoever in a good way. So for example, if I have the category gender, you cannot say male plus female equals something else. So this doesn't work. This is a characteristic of categorical data. Another example is if you have different colors. You cannot say brown plus yellow equals 15. This doesn't work either. So this is categorical data, and with those data I have to work differently compared to data which is scalable. Time, 1 hour plus 1 hour is 2 hours, works. Or height, 1 centimeter plus 2 centimeter is 3 centimeters. So this is data which is scalable, which can be worked on. The third question we have to ask ourselves is regarding the methods themselves. So what do I mean by that? I will tell you the question in a minute. First, you need to hear where I come from. So there is a really heated debate on the internet, which method can be safely used regarding the requirements they bring. So for example, you have the t-test, and the t-test has a few assumptions. For example, that the data is normally distributed, that you have normally distributed errors and stuff like that. And these assumptions are mathematical assumptions on which the t-test was constructed on and performs best on. So what do you do if these assumptions cannot be met? And to make a very complicated topic very simple for you, you should test for a normal distribution every time. That's something I would recommend you. You can do this graphically. So if you have a line, if you do a histogram with your data and the data look like this, where it peaks in the middle and it looks like left and right, the data is sorting itself rather symmetrically, then you can say it looks like a normal distribution. That's one of the methods how you can measure it. The other ones are more mathematically. So there's a test called Kolmogorov-Smirnov test and the Shapiro-Wilk test. These are two tests on which you can test the normal distribution. And I would recommend you to do both methods, so the tests and the histogram, and then you can decide whether you have a normal distribution or not. On the occurrence that you do not have a normal distribution, there are a few things you can do. You can correct your data, but I would be very careful doing that. Or you just use a method which do not have the assumption of a normal distribution. Very easy. Alright, so this should give you a broader overview on the topic on how to choose the statistical method for you. I know I haven't talked about every single method there is. This should give you some helping advice. If you want to have a little tool which will guide you to the statistical tests you can normally use, then just click the link below. Most students really have a big emphasis on these assumptions, and I cannot stress this enough. Most of the assumptions are not that relevant. Do not bother to research for weeks which assumptions can be met, how, and what should you do. Just look at one parametric and you should be good to go. If you want to make your life easier, I have also put down a little statistics tool which is especially made for people who do not have that much statistical knowledge or the ability to really know how to use R, SPSS and stuff like that. So if you want to try it out, you can go to the waiting list down below. This tool will be free, so I hope this will help you on your journey to get your data in the right way. Thanks a lot and bye.